Yeah, a very good evening to all.
Okay.
With great pleasure, I welcome all of you to the 5 days hands-on training on elemental analysis program. This is a third program in this year, conducted by the PSMO College in association with the Spark Institute of Science. PSMO College is an arts and science college situated at Malappuram district of Kerala. A vibrant research activities are going on in the college. The college has recently launched a company to manufacture an electronic device using the technology developed by ourselves. Our principal, Dr. Aziz Zar, is leading all the research activities from the front. His subject is botany. We are proud to say that recently one of his research findings on the COVID prevention medicine has been selected by World Health Organization for their world database of COVID-19. Today, Dr. Aziz Sir was about to inaugurate this function. Unfortunately, he has an urgent meeting. Therefore, he cannot attend this program. I welcome Dr. Aziz Sir for this program. The Spark Institute of Science, we call in the short form that is SIAS. There is a research institute established by a group of researchers from across the globe with an aim of providing training and guidance for graduates and research scholars to excel their career. Dr. Shabil M. Bashir, Dr. Hijaz KM, Mr. Nabuhan, and myself, we are running this institution. SIAS collaborates with other academic institutions and help them to improve their research and academic excellence. The activity of the SIAS will explain in detail after some time. We are happy to say that for this program, around 100 participants, including faculties, research scholars, post-graduation students, and postdoc fellows from different parts of the country and also abroad have registered for this program. We have very good research person for this program. Everybody showed their excellence in their field. Today, the first day, Dr. Holzel Putz, the match software developer from Germany, will handle the session. He has developed the software himself and he updates the software frequently. We really appreciate your excellent work, sir. We are so fortunate to learn such a very useful software from the owner of the software itself. We are very much thankful to you, sir, for giving the free access for 3 months to this software. Actually, this is a paid software. I used this software at NIT Trichy during my PhD studies, where we purchased this software from him. Thank you very much, sir, for giving a free access for 3 months to our participants. I welcome the other resource person. I welcome the Holzen Putz to this program and also to handle the first session. I also welcome Dr. Subhash, Dr. Uwais, Dr. Shivani Sharma, Dr. Abdul Ahad, the resource persons of the coming days. I welcome all of these persons to this program. I also welcome the head of the Department of Physics, Munira Miss, and all the faculties of the department and the allied department in the college also. I mostly welcome all the participants from the different part of the country and also the abroad to this program. Now, I would like to give a brief explanation about the research, the activities of the SIAS, Spark Institute of Advanced Science. Then, after this brief description, our resource person will taking the slide. Just wait. This is a SIAS. We provide special coaching for Airport Authority of India examination. We provide coaching for GATE, Physics, Chemistry and Mathematics, GATE Mechanical Engineering and Computer Science, IIT JAM Physics, Chemistry, Mathematics coaching, Central University Common Synthesis Examination test coaching for Physics, Chemistry and Mathematics. And we have a research forum. You can take the membership and you can conduct the conference and the workshop in associated, and you can do project and internship in our research firm. We will provide the mentoring also. We will encourage the collaborative research work. And these are some of the programs already conducted in the near past. There is 7 days hands-on training on ChemDraw and ChemSketch software, faculty development program on online chemistry teaching, hands-on training on retrieval refinement using foolproof and GSAS, KBPY orientation program, one month Python coding program for the beginners is being conducted now, and today the 5 days workshop on elemental analysis. Most of this program we got participants from different part of the country and also the abroad. These are the upcoming events. On 15th to 25th September 2021, 10 days workshop on stock marketing, 6 days hands-on training on post-mole multiphysics, that will be from 25th to 30th September, and 5-day hands-on training on origin software from 23rd to 3rd October 2021. And the upcoming events continues. 7-day hands-on training on advanced molecular docking, workshop on Gaussian software for DFT calculations, hands-on training on EndNote and Mendeley, hands-on training on latex, from the view of research consultancy, we are developing the material for industry, example the wastewater treatment, and the research analysis. We will do the retrieval refinement of our XRD data of different sample. You can send your sample to us if you don't know the refinement, and we will do the various spectroscopic analysis and the computational analysis. As I mentioned, we have a wide variety of researchers from different parts of the globe. We will also have the publications. If you have any book or any research publication that we will help you, we have a SIAS International publication. This is one of the book recently published by Dr. Shabil M. Bashir. Okay, with this brief introduction, now I invite, before going to invite Dr. Holger, I would like to give I would like to introduce him for the audience. Holger Putz was born in 1968 in Germany. After his PhD from Germany in 1997, he worked at the GMD Society for Mathematics and Data Processing, St. Augustine, Germany. Before he joined the Crystal Impact in January 2001. He continued his work on the enable calculation kernel, and finally, he began to develop the MATCH software. Sir, with this brief introduction, I invite you to handle the session. Thank you, sir.
Okay, thank you very much.
Welcome.
Thank you very much. I would like to start the session by giving a short overview of what the MATCH software is and actually what you can do with it. And finally, I will demonstrate how to use the software in practice and also give an overview, enhanced features that may not be so clear from the first beginning. So what is MATCH? That's what it looks like when the program is running. And it is a software for phase analysis using powder diffraction data. You can perform a qualitative analysis, that is, you can try to find out what's actually in your sample, which materials, which phases. And you can also perform a quantitative analysis afterwards, that is, try to find out how much of the corresponding phase is present in the sample. In addition, you can also set up and run Rietveld refinement calculations using the well-known Rietveld program FullProf. I guess you all have already heard about it. So I will now give a short overview what can be done with MATCH. First of all, after importing your raw diffraction data that you have obtained from your diffractometer, you can do the raw data processing and detect the peaks in this diffraction pattern. I will come to this in a minute, why this is important. Afterwards, you can perform a qualitative analysis, as I have already mentioned, and a Rietveld refinement and a quantitative analysis. What's also possible is to estimate the crystallite sizes in the sample, to calculate the degree of crystallinity, to perform indexing. Basically, if you have a single phase sample, there is only one phase in your sample, you can try to find out the unit cell parameters of this microcrystalline compound in the sample. You can perform pattern decomposition, that is, try to calculate the intensities of the individual reflections, IHKL. This is the only thing I won't cover in my talk today. And you can try to solve a crystal structure from the diffraction pattern in combination with Endeavour. So this is what the program actually looks like when you're running it. It basically contains 4 areas or 4 panes that have different purposes. On the top left, you can see the diffraction pattern graphics. I guess this is self-explanatory. Here you can see your experimental diffraction pattern as well as peaks from reference patterns and so on. On the upper right-hand side, you see this periodic table. Here you can enter restraints. For example, and I will demonstrate this later on, the results from elemental analysis. That is, if you already know which elements are present in your sample and which are not present, you can enter this information here. On the lower left-hand side, we have the candidate list. This is basically a list of phases that may be present in your sample according to a comparison of the diffraction patterns. I will come to this in a minute. And finally, on the lower right-hand side, we have the so-called match list. Here you will collect all the phases that you have decided to be present in your sample. So this is actually the composition of your sample in the end. So let's first start with the qualitative analysis. The basic goal of this analysis is to collect a list of all phases that are present in the sample in the match list, as I have just mentioned. And how is this done? Here you see the match list or an extraction of it. As you see, there are chemical compositions, the names of the compounds, and also the amounts already. And all this is already also present in the analysis report that you can export later on. So this qualitative analysis is based on the powder diffraction pattern, as I have already mentioned. And this is basically the intensity of a diffracted X-ray with regard to the angle 2 theta between the primary beam and the diffracted beam. And this kind of pattern is characteristic for every single phase. That is, every phase or every microcrystalline phase you can think of has a characteristic sequence of peaks, intensities at certain diffraction angles 2 theta. And this is a fact that we can use to identify the phases in a mixture of phases. So this works as follows. You compare the peaks in your experimental diffraction pattern with peaks of known reference phases. That is, you have a large collection of diffraction patterns from known phases and compare every single one of these reference diffraction patterns with your experimental diffraction pattern. And then you can see we have the blue line here in the diffraction pattern. This is my experiment, and green and red are peaks taken from the reference database. And as you can see, there is a good agreement between the positions and to a certain degree also the intensities of the reference patterns in red and green with the experimental diffraction pattern. So these two phases that we have taken here as an example, corundum and quartz, are rather likely to be present in your sample, and so you can select them as matching and can collect them in the match list. How does this work in a little bit more detail? When comparing these reference database patterns to the experimental pattern, Match calculates a numerical value for the agreement, the so-called figure of merit for every reference pattern and stores this in the candidate list. And afterwards, it sorts the candidate list according to decreasing figure of merit, which means that the reference pattern with the highest agreement to the experimental pattern is displayed at the top, and the second one below, and so on. So that's what it looks like. For example, in this case, we have calcite, which has the highest figure of merit, also shown here with this green background in the column FOM. Afterwards, we have quartz with a slightly lower figure of merit, and so on. And now you can select phases from this candidate list one by one as matching phases and enter or add them to the match list on the lower right-hand side, so that you get an overview over the phases that are present in your sample. In the end, you can see in the lower left-hand side of the candidate list, there are many entries with a red figure of merit, which means that it is rather low and it is no longer so probable that these phases are still present. You do not only have to rely on this agreement between the the reference diffraction patterns and the experiment, but you can also enter additional information in match. For example, this is what's most important for this elemental analysis workshop, is that you can enter elements that may or cannot be present. This is quite an important decision because this may help you quite a lot to exclude some false positive candidates and focus on the phases that are really present. It's also possible to use density, color, and other physical properties, or even crystal structure data, and so on. This is the periodic table I have already shown to you. And as you can see, the elements now have different colors. There's most of them are given in yellow, which means that these elements may or may not be present. They are optional. Then we have some red elements. These elements cannot be present in your sample. You can exclude them. They have not shown up in your elemental analysis. We have the green elements. They must be present in every phase that remains in the candidate list. And finally, in blue, this is something which is not used so often. Any of these elements must be present. That is, at least one of the elements marked in blue must be present in all the candidate entries. So this was a really quick overview. I will come to more details in a minute. I just want to show you what you can do if you need some help when using match. First of all, you can use the online help, the built-in. That is, just press F1 and then search for keywords you are interested in. Also, in the help menu, there's a point manual where you can display the manual. Match is delivered along with a comprehensive manual where all the operations are demonstrated in detail and where also a lot of background information is given. And we have quite a lot of tutorial videos on our homepage where several steps and important procedures are demonstrated in practice and explained. And of course, finally, please do not hesitate to contact me by email to my email address given here if you have any questions. I will try to answer them as quickly as possible. It may not always be possible to do so within a few minutes, but I will do my best to do so as quickly as possible. Okay, this was first overview over the program, and now I will show you what you can do in detail with it. Okay, this is what the program actually looks like when you have installed it and run it for the first time. It will automatically display a dialog where you can select the diffraction data file you would like to analyze. And in this very first session, I will use a very, very simple example that is also demonstrated in the tutorial. This is called Quick Start, and I will open it. And as you can see, Match has already performed several steps. The raw data processing, the peak searching, the peaks have already been detected. Here you can see these blue bars at the bottom. And it has also run the search match calculation, that is, calculate the figure of merit for every entry in the reference database and sorted them according to decreasing value. So we have our best matching phase, which is calcite in this case, and I can select it as matching, for example, by pressing this button here at the top. Just click on it, and now Match has copied this entry calcite to the match list at the bottom right. That is, I have selected it as matching and decided that this phase should be present in my sample. At the same time, in the background, it has also subtracted the peak intensities that belong to calcite from the experimental peaks and run another search match calculation. And as you can see now in the candidate list, there is no more calcite given here because the peak intensities are no longer present. And the next best matching phase here is quartz. And I can also select it as matching again, because it looks very reasonable here in the diffraction pattern. There's a good agreement to the experimental diffraction pattern given in blue. And this time I will just double click on it. This is another option how you can select a phase as matching. And again, it has been added to the candidate list here at the bottom right. And again, the peak intensities belonging to this phase have been subtracted from the experimental peaks, and the search match calculation has been rerun, and we have another promising candidate phase here, which is corundum. Again, the agreement to the experimental pattern is really good, so I will also like to select this as matching. This time I will just press the space bar, which is the third option how you can select a phase as matching. And now we have 3 phases here in the match list on the lower right hand side. And as you can see on the left hand side, there are no more matching entries that are all the remaining reference database entries have so low figure of merits values that they are no longer interesting here for this phase. Okay, that's what the qualitative analysis is about. I will just show you some 2 features again. This is the peak list. I can switch over from the restraints tab here at the bottom. And as you can see, we have an overview over the peaks, the peak positions, and the peak intensities of the experimental peaks, and also of the width of these peaks. And here on the right-hand side, we have the intensity values of the entries in the match list, along with the peaks to which they belong. And you can see here, for example, we have a peak marked in red. This means that there's no agreement of this reference database peak to an experimental peak. There's no experimental peak for this. But it doesn't matter because this is just a weak peak and we have several strong peaks which are in agreement. And another second information or a second option I would like to show you here. If you mark one of these entries and click on Datasheet here, you can get an overview over the entry data that are stored in the reference database for this entry. So you have the bibliography and a link to the original entry. We have the space group, the unit cell parameters, the atomic coordinates, and also the diffraction lines here at the bottom with D value, intensity, HKL, and so on. So, okay. Now, as you can see in the match list also, along with the selection of the phases, match has already performed a quick quantitative analysis. That is, it has used the so-called reference intensity ratio method, which is based on the peak scaling factors, to give an arbitrary first quantitative analysis, as you can see here. We would like to improve these values now by running a short Rietveld refinement in order to give some better results. And in order to set up a Rietveld refinement calculation for these three phases and the experimental diffraction pattern, I simply click here on this FP button. FP stands for full prof, indicating that this calculation, the actual Rietveld refinement, is not performed by match itself, but by the full prof software, which has not been developed by us, but by others. Here you have a large amount of options for defining parameters that you would like to refine. For this case, I would just like to use the automatic Rietveld refinement. I don't want to go into all these details at the moment because this is not the purpose of this workshop right now. We'll just run the refinement here below, and you can see the progress of the refinement here with the R factor and the chi-square value. And here you can see that the calculation has now converged. And now the amounts given here below are no longer taken from the reference intensity ratio calculation, but from the actual Rietveld refinement calculation. So at this point, our analysis is now finished. We have a qualitative and quantitative result, and we can summarize it in the report that I can display using this button here. Now we have the report, the licensee, an overview over the experimental diffraction pattern. Now you have the matched phases that were detected in the sample and the amounts, and also the elemental composition. Then some more details about the matching phases. We have the parameters used in the search match calculation. The peak list, that is the list of all the peaks found in the diffraction pattern, along with a letter indicating the phase to which they have been assigned. We have the Rietveld refinement parameters and their results. And finally, some calculations regarding profile areas and peak residual values and the diffraction pattern. And now you can, for example, print or save this to a PDF file or so and store the result of the analysis. Okay, this was the first walkthrough on this on match, and I would now like to continue with demonstrating some more advanced features of the software. We will repeat several steps, but we will also introduce some new commands and options so that you can see what you can also do with match. I will first of all now switch over to the so-called expert mode. Up to now, match was running in the beginner mode, which is default when you first install the software. But once you are used to using the software, it is no longer necessary to do so, and you can avoid that all the operations are performed automatically and perform then manually on your own by switching over to the expert mode. this is done by canceling the file open dialog that is displayed automatically in the beginner mode. And now I will press this button here to display the so-called batch tab of the match options dialog. And as you can see here, match is now running in the beginner user level, and I would like to switch over to expert so that only very few operations are still performed automatically and most of them have to be performed manually. I mark the Save as Defaults option here below in order to make this a permanent selection and not just for the current match session. And I now press OK. Okay, and if I now open a new match document, you see that the file open dialog is no longer displayed and I have to do so on my own. So in order to import diffraction data, press this plus button here at the top right. And I would now like to focus on this sample, which is titanium ore. Open it. Match has detected that the step size of this experimental diffraction pattern is rather low, and for some calculations it may be advantageous to introduce additional data points to interpolate between two experimental diffraction data points in order to get some more accuracy. And I will now confirm that it shall do so. Okay, and now we are applying the knowledge, additional knowledge about the sample for the first time. So assume that we have already performed an elemental analysis on this sample, and we, for example, X-ray fluorescence measurement, and we have found out that there are, of course, the light elements that cannot be detected so easily with XRF, but also silicium, titanium, and iron. And I would now like to enter this information in the periodic table here on the upper right-hand side. First of all elements are set to yellow, which means, as I have already mentioned, that these elements are optional. That is, they may be present in the sample, but they do not have to. And I will now toggle this information to all elements in red. That is, none of these elements may be or must be present in the sample. And I will now switch over to yellow here. And every element that I click on now with the mouse will be set to yellow so that I can select the elements that may be present according to my elemental analysis. As I have already mentioned, these are the light elements. I will just use the first two rows here in the periodic table. And in addition, I have also found that silicium, titanium, and iron may be present. So all these elements in yellow may be present, and all the elements in red can be excluded. And this helps quite a lot to remove entries or to exclude entries that are not cannot be present at all, and that would fill my candidate list maybe and distract me from the phases that are really present. Okay, now I will run the qualitative analysis, the search match calculation, and as you will see, match will automatically detect that there are no peak positions detected up to now, so it will automatically run automatic raw data processing when I click this button. As you can see here, we have now these blue bars at the bottom, so match has detected the peaks and at the same time run a search match calculation. and listed the most promising entries here at the bottom. So again, I can now select these phases as matching in order to transfer them to the match list. For example, the first entry is already marked. I press the space bar. It is transferred to the match list. Again, the peak intensities that belong to quartz are subtracted automatically from the experimental peak intensities. This function is called automatic residual searching. And I will now the candidate list is updated with the remaining phases. And here you see that the next best matching phase is hematite, which is to be expected somehow for this compound. And I would also select it as matching here. But up to now, you see, we don't have any titanium here. And I mentioned that it is a titanium ore. So if you look now at the candidate list, we finally found our titanium in the form of the phase rutile. And yes, I will also select it as matching. And the analysis seems to be finished at this point because no phases are listed here in the candidate list anymore. And just like in the very first example, we now have the list of the phases that are present. That is the result of the qualitative analysis along with a rather raw semi-quantitative analysis. But this is not the whole story, as you can already guess when looking at the diffraction pattern. As you see here, we have the red peaks marked for quartz, the orange peaks for rutile, and the green peaks for hematite. But there are still some peaks left in the diffraction pattern in the experimental that are not covered yet by the identified phases. So at this point, there are several options how to proceed. You can just focus on some of these peaks and run a search match calculation just for these peaks. I will just, at this point, use another option, and I will assume that I know which phase is missing. This happens quite some time when you are repeatedly analyzing phases and or similar samples, and you know already what you're expecting. And let's assume that this is the case here, and how can you enter this information in match. So I know from other similar samples that kaolinite is still missing in my list of matching phases. So what I will do now is search for the phase kaolinite in the reference database. You can do so either by pressing Ctrl F, the key combination, or by clicking on this magnifying glass here at the top right. And now enter the name of the phase. Just start typing. And you will be given some suggestions here. And you see kaolinite is already present here. I press now OK. And as you see in the candidate list, there are now some kaolinite phases that are present in the reference database listed, even though their figure of merit is not so good. This is a feature of this search functionality. And you can now just see, for example, this very strong peak is certainly present here. And there are also some other features that are explained by the kaolinite phase. So I will also now select this as matching by marking this phase and pressing the spacebar again. So at this point, I have now really finished my analysis. And what remains to do again, maybe try to run an automatic Rietveld refinement as before in order to get more accurate values for the amounts of the phases, and then display and export the report. So this is a way how you can use additional information about the sample in Match. I will now show this with a different example that is quite similar, but I will show some other features on this. So let's close this for now. And now import another diffraction pattern. This is iron ore in this case. Again, this is also a diffraction pattern where there's a really large step size, and I will also use the option to interpolate or to add additional intensity points between the experimental points in order to increase the resolution. So as you can see here, quite a lot is happening here on the right-hand side, but here on the left-hand side, you have some kind of primary beam or yes, and yes, I just would like to, well, there's a question. Okay. Yes, I will. But I would now like to remove the left part of the diffraction pattern where there doesn't seem to be any interesting information for my analysis. And this can be done rather easily by moving the mouse cursor here to the left border of the diffraction pattern until the mouse cursor changes, and then press the left button and now move to the right up to here and release the button. And as you can see, the left part of the diffraction pattern has gone. So you can now focus on the right part of the pattern where the main peaks are present. Similar to the previous analysis, I would now like to add additional information. Again, the elements that may be present. And again, I will switch all the elements that are to red from the beginning, and now mark all the elements in yellow, that is as optional, that I have obtained from my XRF analysis. Again, these are the light elements that are difficult to exclude or to decide on with this XRF measurements. And we also have magnesium, aluminum, silicium, and iron again. Okay, with this additional information, I will now like to run search match calculation, again with the automatic raw data processing. So this is the result. And I would now like to focus here on some parts of the diffraction pattern. As you can see here, the automatic peak searching has overlooked some of the peaks, obviously. So we have something here and here and here also. So what I would like to do now is to enter or add these peaks manually. And I will show you how this can be done. You can use the mouse in the diffraction pattern to do so. First of all, I will zoom into this part of the diffraction pattern so I can see these peaks more clearly. Just move here to the left, click the left mouse button until this magnifying glass appears, and draw this yellow rectangle and release the mouse button. And now you can see I have enlarged this part of the diffraction pattern. And as a second second help for my for adding the peaks, I will activate a vertical line at the mouse cursor. I can do so by pressing Ctrl X. Okay, I've done so. As you can see now, we have this vertical line here at the mouse cursor, and I can select the peaks more easily. I will now move to all the places where I assume that there are peaks missing, like here. Press the Control key and keep it pressed. As you see, the mouse cursor has changed. I will now click the right mouse button to add the peak, and I can now release the Control key, and you can see here at the bottom I have now an additional peak at this position. And I will repeat this steps here, and yes, maybe here also. I can keep the Control key pressed while doing so, and yes, we have something, well, maybe here, this one, and this one here seems to be a missing peak, and yes, this one, here is something, this one, and maybe here. Okay, we'll finish at this point. So I have now added some peaks that have clearly been overlooked by the automatic peak searching algorithm, and will now remove the vertical line at the cursor position by pressing Ctrl X again, and by double clicking in the diffraction pattern I will zoom out. So I have now, as you can see here, added peaks that are missing, and I can now rerun the search match calculation. Do so here. Okay, this is the first or best matching phase, hematite, which is not really so surprising if you have iron ore. And I will double click it to select it. And now there's quite a list of other phases, but it's not so clear which one of these is really present in the diffraction pattern or not. So I will use a different approach now for selecting phases, and that is to focus on peaks that have not been covered by identified phases up to now. And I can do so by pressing the keyboard combination Shift Control U, or by using the graphics option, display uncorrelated peaks. Now we'll activate it, and as you see, we have now these light red bars in the diffraction pattern that mark all the peaks that are not yet correlated to experimental phases. And I can now mark one of these peaks. For example, just click inside this light red area and now use this command for searching. And this accepts only entries that contain at least this peak. So we have slightly different search match algorithm when using this command. And I can now see the first phase is certainly a false positive, since we do not have or expect any organic materials inside. But we now have gibbsit, which seems to be matching, which is a quite reasonable phase here, and I can select it as matching by clicking on it. And now you see we have only less peaks marked in light red. So the phases, there's a second phase now, gibbsit, and only few peaks are still not correlated to the identified phases. And I will now continue, for example, use this one for matching and see what we get here. Okay, and now we have a second phase containing iron. This is goethite, and I will also mark it and double click it here. And as you see now, in the candidate list, there are only hematite phases remaining. So we already selected hematite. So these are just some intensities, some peak intensities that were left by subtracting the identified peak intensities at this point. So I can ignore these at this point. And but I expect, or I'm missing another phase, and I would like to check if it's inside or if it's present in the sample, and this is magnetite. This is also an iron oxide, and while in a similar situation, I have used this searching magnifying glass option here, I will now add an experimental magnetite diffraction pattern here in the pattern graphics and compare it to my pattern graphics of my sample. I can do so here by pressing this plus button, and I have prepared a diffraction pattern for magnetite. Open it, select the wavelength, which is kappa K alpha 1. And now you see we have another experimental diffraction pattern here at the top. Here below is my first pattern, and this is the second pattern. This is magnetite. And now I can compare these peak positions to my original experimental diffraction pattern. For example, I can activate the vertical bar again and compare the peak positions here with my experimental pattern. And yes, maybe there's something. What you can also do is move these into each other by moving the mouse cursor to the right and then turning your mouse wheel down. And now the experimental patterns are displayed on top of each other, and you can see, well, okay, maybe here is something, and it is possible that magnetite is also present in your sample. At least you cannot exclude it from this at this point. Okay. Yes, this was the analysis for this sample. If you like and would like to add magnetite to your list of matching phases, you can now repeat the steps as in the previous session. Enter Ctrl F, search for a magnetite phase in the reference database, and double click here to add it to the match list. Okay. Now it has been added here, and you have now 3 phases containing iron and a 4th phase that doesn't. The final option that I would like to demonstrate with this example is how you can preserve the settings that you have made here in the periodic table. If you have repeating analysis of similar samples, it would be advantageous if you could just store this selection of elements and do not have to enter them again and again in future sessions. So what you can do, just use this preset functionality here below the diffraction pattern. You can just press save, enter a name for this selection of elements or for this selection of restraints, and press OK. And if you now come to a similar situation or have analyzed a similar phase in the future, you can just recall it by clicking here in the preset combo box, and you have iron ore here. Click on it, and your elemental selection has been recovered at this point. Okay, that's all I wanted to show with this example. Now I have prepared another one in which I will also demonstrate how you can repeat similar analysis and enter information that you already have, but not regarding the elements, but on a higher level regarding the actual phases that are present. So I will just leave this example, and the following example has been taken from IRU-CR round robin that was performed a couple of years ago. And this was a round robin on quantitative phase analysis for several software packages that were available by that time. And I will just analyze the first one of these series of similar diffraction patterns and open it. So this is the diffraction pattern, and I will now analyze this sample as an example for all the remaining samples that are also available. And okay, I will just have imported the diffraction data, and as usual, click on the button here to run the phase identification. You can also press Ctrl M on the keyboard if you like for this. And again, the peaks have been searched automatically and the search match calculation has been performed. And I can now select the matching phases. I will use this one here, select it as matching. Again, we have this residual searching where the peak intensities of synced have been removed. So I can select the next best matching example, best matching phase here, which is fluoride, and I will select it again. And finally, we have another phase here, which is corundum, which has also been clearly identified. And that's it. So as you see, we have here the result of the qualitative analysis and also a semi-quantitative analysis result, which is also not bad at the moment, but I will improve it with full prof calculation as usual. So I will do retread refinement in order to get even a better result. So the calculation is finished, and I can now tell you corundum, the weight of this was an artificial sample that has been created by weighing some compounds and mixing them. This one was originally 55.1%, fluoride was 29.6%, and synced was 15.3%. So we are pretty close to these weights. So this is quite a good result. But as I have already mentioned, I would now like to show you how you can use this information, the selection of phases, in future analysis of the remaining samples of this round robin, which have different compositions. So I will mark these 3 lines here in the match list, and now I will export this list of files to a so-called match answer set file, which is nothing special. This is just a small text ASCII file where these entry numbers are stored so that you can recall them later on. I will right click here and select Save List As. Now I will use the sample name. Here below you can also export this list in other formats, but for our purpose we need this match answer set file, MTA. There was already a similar file present, so Match will now ask if you would like to append these new entries to the existing file, but I will just like to replace it and press No here. Okay, that's it. I have now prepared an answer set file that I can recall later on in order to quickly perform analysis of similar compounds. And I will demonstrate this right now. I will now open another one of this series of round-robin samples. As you can see here, it looks a little bit different because the amounts of the phases are very different, but I know the phases themselves are the same, just the amounts are different. And now I can right-click here in the match list. I do not have to perform any kind of search match calculation or so. I just right-click here, select Import Predefined Selection, and select the MTA file that I have just created. Press Open. And now Match will load these entries, perform an automatic raw data processing, and also semi-quantitative analysis. And again, I can now, in order to finish my analysis, I can now run an automatic Rietveld refinement again. Okay, and the analysis has finished here at this point. The weight amounts were 95.8% at this point, 4%, and 1.15%. So where we are, again, we are pretty close to this result, to the original value. So the analysis is, again, pretty good. And you can now repeat these steps. This is very quickly analyzing similar compounds for the remaining phases, for the remaining samples. I don't want to do so now. I just want to show you some more features of match at this point. Up to now, we have always used this relative intensities on the y-axis, but you can also switch them because some of the phases are really present only in very small amounts, and you can hardly see the peaks in this with this scale. So I click on this label and select square root of this relative intensities. And now you can see these peaks much more clearly than before. And another option would be this noise here, which was not really visible in the previous scaling, can be removed, for example, for raw data processing. And you can just do so here by selecting the smooth raw data. Now you can see it is even much smoother. So these steps may be useful if you have a rather raw diffraction pattern, or if you have some compounds with really low amounts that can hardly be detected with the X-ray diffraction. Okay, this was it for this sample. And I will now come to some other functions of the software where I would like to perform some other analysis options, like the crystallite size estimation, the degree of crystallinity calculation, and so on. Okay, for this I have another sample. And so I will close this one. My first point will be the crystallite size estimation. And for this, we need a standard. The crystallite size estimation uses the so-called Scherrer formula, which depends on the peak width. And as you can imagine, if you record a diffraction pattern of a sample on your diffractometer, there are two options or two influences that create a certain width of the peaks. For one, you have the sample itself, and on the other hand, you have your instrument, which also creates a certain width of the peaks, even if we have a perfectly crystalline sample. So what you have to do now is to record a standard for your instrument in order to be able to subtract this instrument contribution to the peak width later on from your experimental diffraction pattern in order to get to the real peak widths that are just caused by your sample. So what I have to do now is record and analyze standard sample, and typically this is lanthanum hexaboride. So I have prepared a corresponding file that I assume to have been recorded on the same, using the same conditions on my diffractometer. I open it, select the wavelength. Okay, as you can see here, we have very sharp diffraction peaks, and we will now search for these peaks and at the same time perform a profile fit. So in order to get the width of the peaks as accurate as possible. I will switch over here to the peak list, which is still empty because we do not have found any peaks up to now. And now I will use a peak searching algorithm that is a little bit more, well, a little bit more comprehensive. It does not only search for the peaks, but it also fits the peaks at the same time. So I will use this one. And as you can see here, we now have the peak positions, the heights of the peaks, and also, which is most important in this case, the width of the peaks. And now I can run the command for the crystallite size estimation, which is here present in the quantify menu. Here we have crystallite size estimation. And Match has now detected that up to now no standard is present in the settings. So it asks if you would like to use your current diffraction pattern as a standard, which I confirm. So it opens this additional dialog in which I can also modify these values. But all that I would like to do is save these information, the peak positions and the peak widths, as a preset by pressing this save button here and enter the name lanthanum hexaboride and close this. So I have now stored a reasonable standard for my future analysis, and I can close this one and also this one, and now come to my original analysis that is to the sample that I really would like to analyze. And for this, I will now open a different diffraction pattern. This is this one. Confirm the wavelength, and again run the peak searching that also fits the peak widths at the same time. And I will also run a quick qualitative analysis in order to demonstrate some of the features that are only available if you have identified the certain phases. Oh, please. Okay. So just one phase is missing again. I would like to add random and okay. Yeah. We are. Okay, and can now run the command to determine the crystallite size again. And as you now see, something has changed. I am no longer asked if I would like to, to add a standard, because the standard is already present here at the bottom. And now we have a list of all the peaks, the total width that has been determined from my sample, the instrumental peak from the width from the standard, and the difference. And now the program can calculate or estimate the crystallite size from this sample width using the Scherrer formula and give the result of the calculation here below. What you can also do is select a single phase for the calculation, that is, use only peaks that are present or have been assigned to this phase, in this case quartz, in order to see or get an estimation about the size of this quartz crystallite in the sample. And finally, there's something special here. You have a line marked in red. In this case, the instrument width, peak width, is larger than the total width measured in your diffraction pattern of the sample. So this is certainly an error, and you should avoid using this information. Okay, I would like to finish my presentation of METCH at this point, and am now open for discussion and questions, and will try to answer them. Thank you.
Yeah, thank you very much for the wonderful presentation.
Thank you.
Okay, now I think questions are there in the chat box. Sir, please see the chat box.
Okay. 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 Yes, the question is how to analyze a new composition of nanoparticles. Nanoparticles are not so easy to analyze depending on the size of the particles, because they are pretty small, and it's maybe difficult to have accurate peak intensities. And yes, I will wait for the, and so what you can do is to have different, or to adjust the contribution of different peak parameters to the figure of merit. For example, you can reduce the intensity information, or the influence of intensity deviations if these are difficult to determine. And this is something you can do. What you can also do is, I will just import the diffraction pattern again, and perform raw data processing, is to use the peak positions as restraints. This is something I haven't demonstrated up to now. As you can see, you cannot only use the composition of phases, but also peaks or ranges. And if I mark a peak here, right click on it and select as restraint, give a tolerance, then METCH will only accept phases that contain a peak at this position. So this can be rather helpful to focus on phases that are contribute to this peak and neglect the others. So this is something that you can also do, but it's not always easy, I must admit. If I'm not sure about the second question, if I have only 2 theta and ha, but this is thin films. No, METCH is not really prepared for thin film analysis up to now. So unfortunately, this might become rather difficult, because you can use the features I have just shown in order to primarily focus on peak positions and neglect the peak intensities that may be strongly distorted because of this thin film character. But it's not really prepared, or doesn't have any really special functions for this. Which is the ideal equipment to obtain data? Well, METCH can import diffraction patterns from a large variety of diffractometers. That is, some maybe rather old and some more recent. It's you can then see them on our website, or I can just demonstrate how to use this online feature here. And you can show here, you have a list of all these diffraction pattern file formats that can be used by Match. So we have Bruker, Siemens, GNR, Inel, Jade, Panalytical, Seifert, Shimatsu, Stoe, and also some free formats as well that are described here below. So Match is quite flexible in this case. If you have the crystallite size, if you have only, can I calculate crystallite size if I have only 2 theta and HKL value? This is not possible with Match because the calculation of the crystallite size depends on the width of the peaks, as I have already mentioned. So if you just know where the peak is located and yes, which reflection is below this peak, this is not enough information, unfortunately. Next question, how can we start using Match software if we have only text files containing intensity and 2 theta values? Yes, I have just mentioned Match can perfectly import these text files if you have just 2 columns that contain the 2 theta value and a second column with intensity, and these files can be read directly by Match. What you need, of course, in this case is the wavelength. Match will ask for the wavelength if you try to import such a file, and then you can select the wavelength from this selection box, and then it will be imported. In this context, I would like to maybe demonstrate a feature that I haven't shown up to now. What I have shown is to display a vertical line at the peak position, but you can also display an X-ray spectrum at the peak position. And this feature can be used to check if you have an alpha 1 diffraction pattern or if it is a mixed diffraction pattern, alpha 1 and alpha 2. For example, these peaks here in the center, as you see, we have one peak at the line K alpha 1 and another one at K alpha 2 with half of the intensity. And this is a strong indication that this diffraction pattern has been recorded with a mixed wavelength and not with a monochromatic wavelength. Okay, next question. Is it possible to calculate FHM from 2 theta? No, up to now, because these are 2 different parameters. What you need the diffraction pattern itself. So if you have the diffraction pattern, then of course Match can can determine the peak parameters, intensity, width, and peak positions, and also refine the width and all these parameters. But you need the whole diffraction pattern. It's not possible to use just the 2 theta values for this calculation. The next question is how we will calculate composition of any phase in any materials. I hope that I have demonstrated how this can be done. You just have to perform a qualitative analysis first and collect the phases that are present in the match list here on the lower right-hand side. And if these reference patterns contain enough information, then already a quantitative analysis will be performed. Otherwise, you will have to perform a Rietveld refinement calculation in order to get this information. How to confirm the formation of carbon nitride with Match? Yes, in this case, I will just, there are basically 2 options. For example, you can just search for carbon nitride and check if it is present in your reference database. But in this case, it's not, unfortunately. But if you have a diffraction pattern of carbon nitride, you could import your samples diffraction pattern, add the diffraction pattern of carbon nitride, as I have demonstrated. We'll just show you in this case with the quartz diffraction pattern for this here. And then activate this position and check the agreement. And you can also zoom into these parts and check, okay, well, this is in good agreement, and use this tracking feature I haven't shown up to now. You can, if you are zoomed in, you can keep this shift button pressed and move the mouse to the left or right in order to shift this zoom, and then compare all these peak positions in order to verify this. Okay. Next question, which are the file types that can work with Match? Yes, I have already shown this in the online help. You can also see this on our webpage. This is a large variety of file formats that can be imported. And if you have a file format that is not present up to now, you can just send it to us and we will try to implement this. But up to now, it can it can import a rather large amount of file formats that are very common. And these file formats are determined automatically. You don't have to select which format it is. The question is if it is possible to estimate the cation distribution. I am afraid this is something really special. This is not something that Match has been developed for. I would recommend for this to use some more sophisticated tools, for example, Rietveld refinement with full prof directly, because this is so special that this has not been implemented in Match up to now. Yes, you can. The next question is if it is possible to use organic powder samples with this. Yes, it is possible, but you have to make sure that your reference database also contains organic compounds. I have demonstrated Match here with the default reference database, which is this inorganics part of the COD, the crystallography open database. If you click here on this label below, you can open the reference database library, which is a dialog that shows all the reference databases that are available on, I just have to switch over just a moment, please. Yes, you can, but you can display, it's not shown in the picture up to now, unfortunately, but you can show which reference databases are present in on your computer and maybe switch over to a different reference database, for example, the PDF4 organics, or there's also a full COD reference database available on our webpage that you can download and install. And this reference database contains more than 350,000 compounds. Most of them are organic compounds. And so using this reference database, you can also analyze organic powders. The presentation, yes, I can send the presentation to Rashid, and he can then distribute it to us. So this is no problem. And the whole presentation is also recorded, so I guess you will be able to view it afterwards also. Yes, the next question is if the software is available for free. No, what you can get for free is a so-called evaluation version or demo version. This is a full-featured version and can be installed free of charge from our webpage, but it has the limitation that it only runs for 2 months. So after 2 months, it will refuse operating and ask you to purchase and install a license for it. And for all the participants of this workshop, I have sent a special evaluation license to Rashid that is valid until the end of November of this year. So even if you have already used the demo version and it has expired at your machine, you can install this evaluation license and use it until the end of November. But in general, this is you have to purchase a license for the software. I earn my living by developing this software and cannot do it free of charge, unfortunately. Okay, next one. Okay. For the Rietveld refinement, yes, you do not really need a standard for the Rietveld refinement. What FullProf offers, and which is not implemented in Match up to now, is the uses of a so-called instrument resolution file. That is, you have some additional information about your diffractometer that can be used in the Rietveld refinement calculations, but this is not possible if you use Match in combination with FullProf. I will implement this feature later on during the next couple of months, but it's not possible up to now. Okay, any more questions? Let's see any.
Hello, sir.
Oh, yes, I see. Is the software
good afternoon,
like...
sir.
There's another question.
Yes,
the GCPDS file. GCPDS is now, I guess, the PDF database. You can use all versions of the PDF database and also rather old versions that were published in the 90s with Match, and can create reference database from this if you have a valid license for this still. So this is possible. Okay. More questions?
Yes. Dr. Navin Agarwal, you started to ask something?
Sir, I just wanted to know that how to refer if you are using this program and we are fetching our data. So how to refer that? Is there any kind of reference for that? Like FullProf is there. So
Please excuse me, I didn't understand your question. I'm sorry. Could you please repeat it?
so if you are fitting our data and we
Yes.
are publishing the paper, so how to refer that? How to get the citation? I mean.
Could you please write it in the chat? So I guess it will be more clear to me if it's possible. Sorry.
Yes, I may help you, sir. Actually, his question is, you showed the refinement in the Match software, and finally you collected the output data. He is asking how to cite that information in the journal paper. Means he's asking whether that work that data published in the journal can be visible in that Match software.
Oh yeah, okay. Yes, there's a reference for the Match software, which is given on our webpage and also in the manual that you can use, but it's not mandatory. So just if you feel like it, if you feel that it's important for your research, you can use this citation. And this is just in principle Match software, Crystal Impact, Bonn, Germany, and the version number. So, and there's no scientific publication available for Match because this is all known science and has nothing new from the scientific point of view. But you can use just this reference to our company if you like in your paper.
Yeah, one more thing, sir. I think that if you are taking some data from the Match software,
yes,
then that corresponding paper is also there in the software. I think I can access that paper also. Means paper details.
I'm not sure if I fully understand your question. So if you have some data in Match, and
no, so, I I found that this phase is matching to my compound, and if I need to get the exact paper details, journal paper details of that matched data, can I get it from the Match software?
I'm very sorry that I didn't understand your question.
Yeah,
Sorry.
actually, the question what Naveen Agarwal is asking is this one. Suppose my compound, I matched my prepared XRD data with the match software and found
Okay.
that a particular phase is matching to my compound. And I
Okay.
need to get the journal paper details of that matched phase from the match software. That paper details is available. Can I get it from the match software?
Well, all that you can get is the report. This is a comprehensive document that shows all the identified phases and yes, everything you can that has been found in your sample, and you can export a large variety of data and formats for other software packages. So I hope this answers your question.
Yes, Naveen. Yes. Actually, I also got the data of that, like journal paper details from the match. That is there.
Yes.
Yes. I hope, Naveen, is it clear?
There was no sound in the last two seconds.
Yeah, yes.
Sorry.
Okay, fine. Yeah. Anybody else has any doubts? Sir, for participants, I would like to ask you if anybody wants to purchase this software from you, what would be the price details and other things?
There are several licenses available for the software. It starts with, for an institution, it starts with 599 euros. This is for a single license. That is a license for one computer, can be used on a Windows PC or a Mac or Linux. If you would like to use it on more than one computer in an institution, we have a site license. This offers an unlimited number of installations within a department or institute. The price for this is 1,198 euros. And you finally have a so-called campus license. This is for a whole university or so, and the price for this is about 2,400 euros. This is for academic and non-profit institutions. For the prices this includes 50% discount for academic institutions. If you have a company would like to use it in a commercial company, you have to pay 1,198 euros for a single license and so on. And finally, we offer so-called personal licenses. These are available to individuals only and cannot be purchased by an institution, but the prices are lower. These licenses are time limited. You can get them for 3 months, for 6 months, or for 12 months. And the price for a 3-month license is 49 euros. For a 6-month license, it is 79 euros. And for a 1-year license, it is 129 euros.
Okay, thank you. And, one more doubt. Suppose if I install in my computer the paid version, and unfortunately I formatted my system some other reason.
Yes.
Then next is, can I install the same?
This is absolutely no problem. You can either just reinstall Match after you have reinstalled your computer. You will get for installation by email a license file and installation instructions, and can just take them again from this email. If you have lost this email also, it's no problem. Just contact us. We will send the delivery email again and replace the license and so on. So this happens several times a year by some customers, but this is no problem.
Okay, thank you.
So there's one more question, how to get a paid version of our match software. You can just visit our webpage, which is www.crystalimpact.de or .com, and there you can go to match and how to get match software. And we also have an online store where you can directly purchase a license, where you can also pay by credit card and PayPal. So, or just contact us by email, and we will get back to you soon. Okay, any more questions?
Yeah, I think no more questions. I would like to say one thing. Actually, this software really helped me because most of my samples were multi-phase sample. I was struggling with that sample, and this software helped me, and I could publish that data. I did a refinement after knowing the phase, and it was really worth this software.
Yes, thank you.
If no more questions, we can thank the speaker.
You're welcome.
It was we are very. So one more question, I think, in the chat box: how to get unit cell?
Yes, this is something I haven't demonstrated because of the limited time. I can do so right now, if you like, or if it's okay. It's a rather quick demonstration. So Match can index the unit cell or index a diffraction pattern to obtain the unit cell with TRIO or DIGVOL. And in order to do so, you just import the diffraction pattern. I will show this with quartz again and select the wavelength. Here in this case, there's some kind of artificial hump here at the left that I will exclude now. And now you just press this button here, which means indexing. Match will automatically perform raw data processing and peak searching. I will use TRIO for the analysis for the indexing, use the standard parameters for TRIO. And now it has found the unit cell, as you can see here. And yes, you can accept it. This is the correct unit cell. You can now focus on the crystal system and the space group. You can try to use extinctions, systematic extinctions in the diffraction pattern to restrict the number of possible space groups. In this case, this is the correct one. And now, once you have settled on this unit cell and space group, you can export this information to the match list by pressing this button here and close it again. And now you have a so-called manual entry here in the match list that contains your unit cell data. And you could now even forward this information along with the diffraction pattern to Endeavor, our software for crystal structure solution, in order to solve the crystal structure.
Yeah.
Okay, yes. I hope this answers your question. Yes, okay.
Yeah. Okay.
Sir, another one question. Sorry to interrupt.
Okay, no issue.
Sir, if I want to invite sir to give another lecture on this one match software in our institute, even in online also, is it possible, sir, or is free, sir?
Please excuse me, I haven't understood your question. Could you please write it down in the chat? So this is a little bit easier for me. Sorry. Thank you.
Is it are you available to give a invited talk on this software in our institute, sir?
No, we don't do this normally because we're just a very small company and just two people, and we do not have time to move abroad and present the software at other locations. Sorry.
In online also no problem, sir. Online also no problem, sir.
Okay, thank you.
Yeah, I think let's limit the question. This is the last one. Sir, last one question is there. Can we do the structure refinement in the chat box?
Pardon, what kind of refinement?
I think please see the chat box. That is a, can we do structure refinement? Structure refinement.
Oh yes, okay. Well, you can do so using full prof again, the Rietveld, using Rietveld refinement. This is yes, refine the unit cell parameters, refine the atomic coordinates, and all things like that. I can just show you here how this is done. Just a moment, please. I will just reload this one again and select the phase. So in order to run Rietveld refinement, and you can, okay. Now here, I haven't demonstrated this in the sessions. This Rietveld parameter turn on dialog, I've always used this automatic Rietveld refinement, but there are a large variety of parameters that you can refine. For example, here on the expert tab, you have quartz, this is the phase. You can refine stress strain, and you can also refine the crystal structure. That is, you can select the unit cell parameters that you would like to refine. You can select the atomic coordinates you would like to refine. And yes, this is possible.
Okay, fine. Thank you very much, sir. Actually, this is extremely useful for all the audience.
You're welcome.
We will provide the recorded video to them, and they will practice themselves. And if anybody needed the software, they will contact you back.
Yes, thank you.
Okay. Thank you, sir. Thank you very much for spending valuable time with us. And really, yes, this is very valuable information for us.
Yes, okay. Thank you.
Thank you.
Thank you. Bye.
Thank you. Thanks to all the participants. You have cooperated very well, and we will meet you tomorrow for the next session. Thank you.
Sir, today I have not received the mail, sir. I got a little bit late in the WhatsApp call, so please.
Okay, dear participants, I have a kind request. Please check your email regularly, because all the updation will be sent to your email. And no problem. After I think 1 or 2 hours, we will send you the link of this recorded video, so you can practice yourself. And if any doubts, you can contact to us, and also you can contact to the doctor, our resource person.
Sir, when we use it, actually, if we use it actually, can you people help us, or we'll have to contact him?
Yeah, actually, one thing, this time, the software, once you install to your computer, you will get up to a limited time. If you do this fast, means within the few days, then we can help you. Because when you send some samples, or if you ask some doubt, sometimes we may need to run from our computer also. Okay. That's why that thing you have to take care.
Okay, sir. Thank you.
Hello, Rashid.
Yes.
Sabir here.
Shabil.
So somebody said they didn't receive the mail. So it is. I mean, please send a request for that to our mail. Then we can easily track you are in the participants list or not. So so I request that the participant to send a mail, or at least he can put in the chat what is his name or mail ID, the registered mail ID. Then we can track the thing. And the recorded video, I think Dr. Rashid may explain you that you will get the recorded video in the app, if you are using Android mobile phone, or if you prefer the web, we have the link. So yeah, we will. You can access the recorded videos too, because the it's a training. You have to use the software with a single session. You may not know everything, so you have to work it on that. Then only you can be an expert in this thing. Okay, we can end the session here and see you tomorrow. And no need to put the your mail IDs. Those who registered and they are not getting the emails, they have to put in the. I mean, it's better to send a mail, then we can easily track it. The mail ID is not registered in the participants list. Madhukar BS.
Yes, sir.
Hello. You. I mean, yeah. In our list, your name is not there, so you can send a request again. So
How to
if
send,
you
sir, to
want
the
the.
which mail ID I didn't have on the.
Oh, okay, I'll put the mail ID here, so you can.
Okay, sir, I'll write.
And okay,
From
okay.
tomorrow I'll get the mail, right, sir?
I mean, yeah, send a request and we will look on that.
Okay, sir.
And for the other Varshini, uh, for her too, her name is not in. I mean, I don't know if he or she. That candidate, that participant's name is not in the list, so uh, you can also send a mail to the our mail, sparkinstituteofscience@gmail.com.
Yes, as Shabil said, you can send your queries, any problems to the Spark Institute of Science at gmail.com. And also mention that your registered email ID with us. Please use that registered email ID for the further communication. That will be easier for us. Okay, dears, we will meet tomorrow for the next session. Bye.
Bye.